Yes, we have started with the recording. So, welcome, guys. And we are starting with the day 2 session of Introduction to Statistics for Data Science. Okay, I'll hand it over to you, Matrisha, to take the session ahead. Thanks a lot.
Okay, thank you. So, concepts once again because the new join is there. So, Abu, do you have any idea what is frequency or anything? So, do you have any idea what is frequency? You can speak or you can write it down. Okay, so right. So it's an occurrence means a value how many times it's occurring. So that is what frequency. Frequency of value of the variable is the number of times it occurs. Now what we have here, we have an unstructured data like daily number of car accidents for last 30 days. Okay, we have recorded it and see the for first day we had 4 accidents over there, second day 3 accidents, third day again 4 accidents. Okay, in this way we have data for 30 days, monthly data. Now if you want to analyze it, so first what you need to do, you need to give a structure to this data, right? How will you do it? So you have some values, right? 4, 3, 5, 7, and how many days it's occurring or how many times the same value is occurring. So that is our frequency distribution. And see this table here. Daily number of car accidents is 3 and frequency is 5. So how many days were there when 3 accidents occur? So in this way, if we just give it a tabular form, we get a frequency distribution table. Okay, so why we are calling it simple frequency distribution? See, here we are having isolated values, right? 3, 4, 5, 6, no range is there. So that's why we are calling it simple frequency distribution. Now we might have group frequency distribution as well. When we are talking about you a range, it's actually giving you a range. It's from 15 to 19, 20 to 24. So I'm getting a range, and within that range how many people are there. Suppose this frequency is showing like 15 to 19. In this age group, how many people are there in my class? 20 to 24, how many people are there in my class? Okay, so this is what our group frequency distribution. Now, when we are dealing with this group frequency distribution, we should know some concepts, right? Ravinder, you attended last class, right? So I hope it's clear to you, this simple and grouped. Okay,
Yes,
yeah,
yes.
just give me 2 minutes because Abu is totally new. So just I'm repeating the things and then I will start the cumulative frequency part. Okay, thank you. Frequency distribution, we should know some concepts. What are those? One is, what is class interval? You see in 20 to 24, this range is termed as class interval. Okay. Now, in that range or in that interval, the frequency what I'm getting here in first range 15 to 19 in this class interval, what is the frequency? 37. So we are calling it class frequency. in a particular class, what is the frequency? Okay, so that is what our class frequencies concept. Next is class limit. It's very simple. In a range, you are having an upper limit, an upper part, okay, and the maximum value and the minimum value, right? So in this range, in this 15 to 19, in this range, what is your lowest value? 15. And what is your highest, the maximum value? That is 19. So the lowest value right above. So our lowest value is termed as class limit. So this is your limit, we used to say, right? So this range is having some limit. One is lower limit, another one is upper limit. So the minimum value of a particular class interval is called lower limit, and the maximum one is called upper limit. Okay, now here the concept of class boundaries. Now we are going to discuss the concept of class boundary. See, here you can see that this is a discrete in nature. Discrete means it's isolated. It's not like continuity is there. 15 to 19, then there is a gap. Then it's starting from 20 to 24. If it is continuous in nature, what would be the structure? 15 to 19.5, 19.5 to 24.5. In that way, we should get, right? There should be continuity. So the first class interval's upper limit should be equal to the lower class intervals, lower class limit of next class interval, right? That means if it is continuous in nature, so this 19 should come like 19.5, and it's the 20 should come like 19.5. So there is a continuity. There would be a continuity. But here we can see it is discrete in nature. 15 to 19, then there is a gap. Then it's starting from 20 to 24. Then again it's starting from 25 to 29. So this is not continuous in nature, right? So for further analysis, sometimes we require to convert the number in continuous. Okay, how will you do that? When we are converting the discrete number into continuous, then actually we are getting class boundaries. What is class boundary and how to calculate it? First thing, we should know how to calculate it. Now, consider the first class interval. It's 15 to 19, right? This range. What is the upper limit of this range? It's 19, right? Keep it in your mind. Now, come to next range. It's 20 to 24. Consider the lower limit of that range. So it's 20, right? Now, what is the difference between 20 and 19? Means the lower limit of second range and the upper limit of first range. This 20 and 19, what is the difference between these two numbers? Guys? Right. So it's 1. Then there is a formula. You have to divide this number 1 by 2. So 1 by 2. Why we are doing it? Because we want to get the average, and we will use this average in our ranges to make it continuous in nature. So 1 divided by 2, what we are getting? It's 0.5. Now 0.5 would be deducted from each class interval's lower limit and be added with each class interval's upper limit. I'm repeating. What you have got, the lower limit of second range and the upper limit of first range. First, we have calculated the difference between these two. we have got 1. We are dividing it by 2, so we have got 0.5. Now, 0.5 would be deducted from each class interval's lower limit. That means from 15, from 20, from 25, from 30, okay? And would be added to each in class intervals upper limit. That means it will become 19.5, 24.5, 29.5, 34.5. So ultimately, no, it's, yes, upper limit of first range and lower limit of second range, right? And it's true for each range. If you see the ranges differences, suppose here you are having 15 to 19, here you are having 20 to 23, then starting from 25, then we can't use this concept. The difference of each range's upper limit and the next range's lower limit should be constant. So yes, upper limit of first range and lower limit of second range. Okay? And if you start from second range, the same thing you will get. If you take 24 and if you take 25, that means the upper limit of second range and lower limit of third range, the difference would be same. If the difference differs from the first one, okay, then we can't use this concept. The difference of each range's upper limit and the next range's lower limit should be constant. Here we can see the difference if you consider this first two, or if you consider this second and third one, or the third one and fourth one, always you will get the same difference. It's 1. Then you are dividing by 2, 0.5 you will get, and that 0.5 you have to deduct it from each range's lower limit and add with each range's upper limit. Okay? Now have you got it? Okay. Great. So this is how we calculate the class boundary. Now the lower limit is called as lower boundary and the upper limit is termed as upper boundary. When it is continuous in nature, the data is continuous in nature, the limits are, the word limits are not used. There we are talking about, or always we call it boundaries. Upper boundary and lower boundary. Hi Rajamani. So we were discussing, right, we are discussing about frequency. Okay. Guys, if you people face any, yes, Rajamani, you want to say something? Okay, so next concept is what is width. Okay, difference between the lower and upper class boundaries is called width. Okay, we are having lower class boundary and upper class boundary. If we take the difference of these two, we are calling it width. And what is frequency density? Class frequency we have. Class frequency means actually the frequency which is lies in a particular range. So class frequency dividing it by width of the class. So we are getting frequency density. I did the first one for you people, when you will receive the, if you have already received, or if, in future if you receive the file, then the first one is done. Okay, don't copy paste it. Every time I tell my students that don't copy paste it, do it by yourself, at least for this second line or third line, because there is a calculation. You need to look at the formula and you have to do it. Once the concept is cleared how to calculate it, then you can drag it or you can leave it in that way. Okay, so not an issue, but the first one is done by me. The second, at least the second one should be done by you. Means the second line should be filled up by you manually. Okay. So what we did here, the tabular form, what we have got the data for the group frequency. I just put those values over here. So what we are having interval. We are having class intervals. Then we are having class frequency. We are having class limits. So what is our class limit? Is lower class limit is 15, upper class limit is 19. Then we are having class boundary. How to calculate it? Consider this 19 or 20. So what we are having, the difference is 1, dividing it by 2.5 we are getting, adding it with our all ranges upper limit and deducting it from each ranges lower limit. So what we have got is 14.5 as our lower boundary, 19.5 as our upper boundary, with the difference between the upper boundary and the lower boundary. It's 5. And then frequency density is class frequency, this 37, dividing it by width of the class, that means 5. So we have got 7.4. So till this, is it clear? This is what the concept of frequency. Rajamani, can you hear me? Abu, Ravinder, it's clear, right? Or do you have any query or any doubt? Okay, Rajamani. So, okay. Ravinder and Abu. Abu, are you clear? Then we will proceed. Okay. So our next topic is frequency distribution, but cumulative in nature. What is cumulative? Now we all have like recurring deposit, right? Recurring deposit. So when the interest rate is calculated, okay, it is what? It is compound interest. It is cumulative in nature. The interest we also got, it is cumulative in nature. So what is cumulative frequency? There are two types of cumulative frequency distribution. One is less than, another one is more than. So the same data I'm using, the age is 15 to 19, 20 to 24, 25 to 29, these ranges I'm having, along with its frequency. And we already calculated the boundaries. So we took the lower boundaries of each range. So we are having 14.5, 19.5, 24.5, 29.5, 34.5, 44.5 and 59.5. Now, the question is, if I ask you that what is the number of students in my class whose age is less than or below 14.5? How many students are there whose age is below 14.5 according to this data? Is there anyone whose age is below 14.5, guys? Right. Ravinder, you also agree? And Abu? Okay. So it's 0. So the less than part, less than frequency is starting from 0 because no one is there whose age is below 14.5. Now next question is, how many people are there whose age is below 19.5? So I will take that range from 14.5 till 19.5. So 37 people are there whose age is below 19.5, right? So here it is, 37. Now next question is, how many people or how many students are there whose age is below 24.5? So we are taking into account two ranges, right? First is that range is 14.5 till 19.5. Another range we had 19.5 till 24.5. So this 37 and 89, both this frequency part would be added and we will get this 118 as our frequency when the question is, how many people are there whose age is below 24.5? Right? So in this way, we will keep on adding and at last see how many people are there whose age is less than 59.5. So we have in total 200 students. Okay. So no one is above 59.5, right? This is my maximum or upper limit or upper boundary. So everyone's age lies below this 59.5 value. So we are having 200 students whose age is below or less than 59.5. So what we did, we keep on adding the frequencies and at last we got the total number of students. This is actually checkpoint. The total frequency should be equal to this number. If you are getting anything else, then that means you have made some mistake in calculation. Okay, so you can consider this value as your checkpoint value, whether you have calculated it correctly or not. So this less than concept is clear, guys? Okay. Rajamani and Ravinder, more than is just the opposite one. We are starting like how many students are there whose age is above 14.5. So obviously everyone's age is above 14.5. So in total, how many students we have? It's 200 students, right? So everyone's age is above 14.5. So here we have written 200. Now next question is, how many people's age is above 19.5? So what we should do, we should deduct this class frequency because here my class boundary is 14.5 till 19.5. So their age is not above 19.5, right guys? So that's why what we did, from 200 we will deduct this 37 and we got 163. Now next come to 24.5. How many people are there, how many students are there whose age is above 24.5? So we should deduct this 81 as well because within these two ranges the people's age lie between what? 14.5 to 24.5. So their age is not above 24.5. So from 163, we would deduct this 81 and we will get 82. So in this way, we will keep on deducting, and at last the question is, how many people are there whose age is above 59.5? There is no one whose age is above 59.5 because we have till 59.5. This is our uppermost class boundary. So we have 0. So this is another checkpoint. For less than, at last you should get the value which is equal to the total frequency. And in more than type of cumulative frequency, at last you should get 0. So if you are getting anything else, then that means you have made some mistake in calculation. Thankfully, you don't have to do anything manually because you are going to use some software. We have a very advanced and intellectual software. They will do this calculation. So human error would not be there in case of calculation. Okay, but this is the concept how to calculate the cumulative frequency. Now if we, Rajamani, actually we already discussed this class in each class interval 19, 20 to 24. We are having ranges. We are calling it class intervals, right? It's fine, Rajamani. I'm just repeating. It's 15 to 19, 22 to 24. These are the ranges. We are calling it class intervals. Okay. Now, in each class intervals, you can see one maximum value, another one is minimum value. So this minimum value is termed as lower limit, and the maximum value of each range is called upper limit. Okay, so here for the first range, for the first class interval, the lower limit is 15 and the upper limit is 19. Then come to the next range, the lower limit is 20 and the upper limit is 24. So in this way, we calculate the lower limit and upper limit. It is already given. Now, this is discrete in nature. You can see the upper limit of first range is ending it at in what? Is ending at 19. Then the next range is starting from 20. So it is isolated in nature. This is discrete in nature. This is not continuous. If it is continuous in nature, it looks like 19.5, 20, and 19. I mean, the upper limit of first range would be like 19.5, and the next range's lower limit would be 19.5, right? So then we can call it continuous in nature. But here we can see it is isolated. So if we want to make it or convert it into continuous data, then we will require the concept of class boundary. How to calculate class boundary? Consider the first class interval's upper limit. So here, what is the value of our upper limit? It's 19, right? And then come to the next range's lower limit. Consider the second class interval's lower limit. What is the value? It's 20, right? Are you getting my point? So what you are considering? The first class interval's upper limit and the next range's lower limit, 20. Now what is the difference between these two? 20 and 19? Rajamani? 1. Divide it by 2. There is a formula, okay? The difference what you are getting between the upper limit of one range and the next range's lower limit, divide it by 2. So what we are getting is half. Half means 0.5. Now this 0.5 would be deducted from each range's lower limit and would be added with each range's upper limit. So 15 minus 0.5, 20 minus 0.5, 25 minus 0.5. Okay, and 19 plus 0.5, 24 plus 0.5, 29 plus 0.5. So ultimately, what we will get, we will get 14.5 for this range, 15 to 19. For this range, we will get 14.5 lower part, and the upper part would be what? 19.5. Now the next range would be what? 19.5 and 24.5. Then again, for this range, this 25 to 29, for this range, what we will get? The lower part would be 24.5 and the upper part would be 29.5. Okay, so then we are calling this minimum value of this continuous data class lower class boundary and the upper value as upper class boundary. Have you got my point? Rajamani, is it clear how to calculate class boundary, or should we repeat? Okay, great. So now it's clear, right? Okay, and the cumulative frequency we discussed okay, there vertically we use this cumulative frequency and here we use the values. Okay, so this is actually class boundaries. So here the max value is given. If we consider, okay, just a second. See, sometimes what we require, we actually need to use some calculation on continuous nature. Okay, it has some advantages to use continuous data. Okay, suppose if it is not in continuous in nature, if it is discrete in nature, we might face some problems, like suppose it is normally distributed or not, if we want to check. So there is an assumption that the data should be continuous in nature. So that's why we should get the continuous data. But sometimes what happens, we got the discrete one. Or suppose you want to calculate the cumulative frequency. Okay, there we can't use the discrete data. There we need to use the continuous data. Okay, because you want to know how many people are there whose age is below 55.5. Then actually what you need to do, you need to calculate the class boundaries, because the cumulative frequency is calculated on the basis of class boundary and which is coming from the continuous data. Okay, so that's why sometimes we need to convert, but ultimately when you will do the projects, okay, and you will use some software like R or SAS, then you don't have to convert it, because most of the time we are getting the data which is continuous in nature or binary in nature. Okay, so you don't have to apply these concepts over there, because our system, we are having a very intelligent software, so they will do all the calculation. But if you suppose you want to use the cumulative part, cumulative frequency, or some assumptions you want to test, which are totally based on these uh, assume that the data is continuous in nature. That time you need to convert the data into continuous. Okay, have you got my point? Mainly for the cumulative frequency and all those things, we require the continuous data. Okay, but you don't have to calculate it manually. The software will do it, just to make you understand what is the concept and why we require this. Rajamani, is it clear? Okay, thank you. Okay, so ogive is not used usually, but as because it's a statistics class, so we should know each and every concept. And I would like to tell you that, see, the way we have structured our syllabus is totally, keep it in mind that how the statistics is used in practical world or in analytics world. There you don't have to remember the formulas because formulas are available in net. What you should know the concepts. That means when to use what concept, that you should know. And suppose you are getting one result, we will proceed to that level. So you are getting some output or result. So looking at that result or output, what will you interpret? That is the main thing. Okay, so somewhere I will show you some formulas and somewhere I will tell you that for the time being, don't give importance to this formulas because formula is important. Some formulas are important for apti. For interviews, no formula is required because no one is going to ask you the formulas of statistics, and especially if you are not from the non-statistical background. Even if you are from statistical background, from my experience I can tell you, no one is going to ask you the formula. Okay, so they are going to ask you the interpretation that this result you are getting, okay, how will you interpret it? Or suppose there are two concepts and this is the situation, which one will you choose? So you need to know these things. So we have structured our syllabus in that way so that you can understand the interpretation and your concept would get cleared enough. Okay, and that is enough for your analytics part. Okay guys, so our frequency part is done. Now come to the chart part. I would not take a lot of time for this. Just two things I need to discuss. Suppose you all know that we are having so many types of diagrams, mainly the line diagram, bar diagram, column diagram, pie chart. Okay, so I'm not going to tell you how to draw it or how to use your Excel or R to draw it. I'm not going to teach you because it's very simple, and hopefully you all know how to draw it in Excel at least. So my question is, when to use line diagram? Means for what type of data? Okay, or for what kind of analysis you'd require to use this line diagram concept? Can you tell me, guys? You all know what is line diagram. You all know what is pie chart. Okay, from our class 9-10 we actually know, and now we can do it in our Excel or in any type of software, right? So my question is, when do you use line diagram? For what type of analysis or for what type of data do you use? Any idea, guys? Very good. You also joined late. Okay, Abu. So numbers are increasing, decreasing. Okay. No issue part. So you are getting the points. We discussed the data types last day and frequency today from the beginning only. Now we have started the chart part. Okay. Okay. So Ravinder and Rajamani, do you have any idea when do we use this line diagram? Okay, great. So trends. Abu, you are actually right. When it is the value is changing and the decreasing, actually the term we use is to show, to see the trend. Okay. Uh, it's a statistical term, you can say. So in interview or any analytics world, if anyone asks you that line diagram is used to see what, then if you see like it's increasing or decreasing, it's not the, it's actually the concept, but the term is trend. Okay, to check the trend. Right, very good. And what type of data we are using? Time series data. What does it mean? Means the value is changing, right, over the period of time. So that's why for time series data, to check the trend, we are using this line diagram. So trend analysis. Okay, and for time series data type means, what is time series data? When that value of a particular variable is getting changed over the period of time, then we are using this line diagram. Also, you can use but the line diagram is the famous one. Okay, and it depends on the way you want to present, right? Because visualization does matter. Okay, so line diagram you can use if you see the production, or for the, suppose you want to use the column diagram and bar diagram, it depends on you. Okay, and how you want to visualize your project, how would you like to present your presentation in front of your client, it depends on you. But line diagram, column and bar diagram, both can be used for your time series data. Okay, when the value is getting changed over the period of time. Okay, now another right. So can you tell me when do we use this pie chart, guys? Pie chart, percentage. Okay, percentage or proportion, right? Great. So here, right, the difference between the line diagram and the pie chart is, here the time period is constant. I want to see, suppose in 2010 or 2015 there was a production, and I want to check how many types of cost I might have in my production level, right? I want to check that percentage of different cost of production for the year 2015. So here I'm not using any time series data because time is constant. So if anyone asks you like for time series data, can we use this pie chart? No, we can't see the trend using this pie chart. For different years, we can plot the pie charts and then we can compare. That is something different. But pie chart is showing you the percentage and the year is constant. The time period is constant. It's not variable. Okay, so this is the main difference between the line diagram and the pie chart. Great, guys. So it's clear, right? Path, Rajamani, Ravinder, Abu. Okay, great. So Parth and Ravinder, Abu, it's fine. Okay, great. So our next topic is central tendency. Yeah, words actually. You will get the videos and the document. Okay. It's very simple topics and very, very, very important topics. Let me, clarify it. It's very important. And the next topic, what we are going to do, central tendency. You can expect one question in interview from this part. Okay, so don't give much importance to the formulas and all those things, because I told you that the concepts are very important. So if you are not getting any point, ask me 1,000 times, I have no problem. Okay, and yes, you have to spend some time after the class so that you can revise the concept, and so that in future you will never forget it. Guys, just give me 1 minute and then I will start this central tendency concept. Okay, guys. So, so the famous topic we are going to discuss. Anyone don't know anything about statistics, but they know this concept. That is what, right? Mean, median, and more. So this is the famous and the very, very important topic from our statistics, right? So central tendency is actually the average. Now, can you tell me why it's so important sometimes to know the average of something? His average. So why we always want to know the average? What average is indicator of something, right? So what is that? Okay. Okay, Abu, to get estimate, and then Parth, Rajamani, Ravinder to set threshold. Okay. Rajamani, okay. And Ravinder and Parth, describe the data. Yes. So average means if suppose Ajit comes and asks me how the students are performing in your class. So if I say they're very good on average, it might happen like suppose if I'm having 50 students in my class, 2 3 students are not performing so well, but most of the students are performing very well. So obviously what I would say that on average they are very good, okay, or they are brilliant, or they are responding very well. So it is actually representing the nature of a data set. So what you will get when you are in analytics domain, so what you will get, you have to deal with the data. You will get a set of data and you have to understand that what is the nature of this data on average, how is it, right? So it is actually a representative or typical value of a whole set of observations, right? So in statistics, the theory based on average is called central tendency, because average is always taking the central position, right? So central tendency. Now there are mainly three measures of central tendency, the very famous three concepts: mean, median, and mode. Now mean has mean can be divided into three more categories: arithmetic mean, geometric mean, and harmonic mean. The note is there, but I'm not going to discuss that geometric mean and harmonic mean. Why? Because when you will do the analysis, mainly we are actually using this arithmetic mean concept, the simple average what we use in our day-to-day life. So that's why there is another note in a Word document. You will find it there. The example and the definition is given of geometric mean and harmonic mean as well. You can go through it only to clear your concept. But ultimately, we always use this arithmetic mean concept. And what is arithmetic mean? It's simple average what we do, okay, in our day-to-day life. So here is a set of observations I'm having. It's 2, 5, 8, 4, 6, 9. Just summing up those values, dividing it by the number of, how many number of observations are there? It's 6 observations are there. So number of observations, and we have got 5.67 as our mean. This is our arithmetic mean. Now, mean is a very good, measure of central tendency, and it's robust in nature. It is very good in nature. But there is a problem with this concept. Okay, we already have mean as our measure, but in your analysis or when you will start analyzing data, then you will find that most of the cases you need to compare between mean and median. What is median? The set of observations you have got, you are arranging it in some order, either in ascending or in descending. Naturally, we do it in ascending order. You can do it in descending order. And the middlemost value, the value is taking the middlemost position. That is your average. So here we are having 5, 4, 2, 1, 3. These values we are having. I have arranged it in ascending order. This 1, 2, 3, 4, 5. And we took the middlemost value 3. So this is our median, or this is our average. Okay. Now, in analysis, there is a term which is called outlier. Outlier. Okay. OUTLIER. So outlier means extreme values, either very low value or very high value. Suppose we are having here 2, 5, 8, 4, 6. In place of 9, suppose you are having 900. In place of 9, if you are having 900, what problem will you face? In place of 9, you are having 900. You can see this average would get changed, right? Okay, so suppose this is so your value would get changed. Here you have to show it. Anyway, so again the calculation I need to do. You can understand that if I'm adding 900 in place of 9, so this average 5.67 would get changed, and much higher value we will get. So if we are getting much higher value as our average, suppose we have got 100 as our average. For an example, if we add this 900, we have got 100 as our average, let's say. Now, we can see most of the values are 25846. Okay, much below compared to our average, right? So if there is any very large value, any very big value or very extreme value, that value is affecting the average. Now if I find 100 as my average, what I told you, average is a true representative of your data set. So what you will assume, that most of the data of your data set would be close to 100, right or wrong? But it's actually not the case, because most of the values are much below than this 100, right? So here the average is not showing you the true picture. It is not the true representative. This is the problem with our arithmetic mean concept. Got my point, guys? Abhupat, Rajamani, Rabinder? Okay, Ravinder is clear. Okay, thank you. Abu, I was just telling you, suppose what you had here. Here you are having 9, right? Here you can see 9. Okay, so in place of 9, thanks Parth. So in place of 9, suppose if you are having 900, this 5.67 would get changed. Much higher value will you will get, right or wrong? Abu? Right. So suppose I'm expecting that 100 would be the new average. Now, if you compare these values with this average, what I told you people, average is a true representative, right? So if you see this 100 as your average, what would you expect? That most of the values of your data set should be close to 100. But this is not the case. Most of the values you can see here, 25846, it is not close to 100 at all. So this 100 is not the true representative of your data set, isn't it? Abu, have you got this point? Let me know, please. Okay, so this is the problem lies with the measurement of arithmetic mean. If there is any extreme value, the average is getting affected by that extreme value. We call it outlier in analytics world. So outlier is affecting, the average is getting affected by our outlier. So here we use median, or here we can use median. How to do it? Suppose in place of 5, if you are having 500, it's not going to affect your middlemost value. When you are calculating median, what you are doing? You have a data set, you are arranging it either in ascending order or descending order, right? And then you will pick up the middlemost value. See, Parth, the thing is that we are not going to do it manually. I will tell you how to do it. Okay, how to detect the outlier. Let me finish this median concept, and then I will tell you how to detect the outlier if you are having not 1,000, if you are having 1 lakh or 1 million data. Okay, so, and that's why we are using these softwares. So median is the concept what? Yes, Parth. I will tell you. I will tell you. Even it is in our concept, extreme values. I have added that one. Okay. So suppose in place of 5, now if you are having 500, will it affect your median? Let me know, please. Let me know your answer. Abu? Median is what you are having a set of observations, then you are arranging it in ascending or descending order. Then you are just picking up the middlemost one as your average. Now, in place of 5, if you are having 500, will it affect your median? Abu, Parth, Rajamani. Okay, Ravinder. No, Abu, no. That means if there is any extreme value, it is not affecting your average when you are using the median concept. Okay, so we get to know that outliers are affecting your mean, outliers are not affecting your median. Now Parth asked me, here it is very simple to calculate, right? We can find out only if you are having 5, 6, 10, even if I suppose 50 or 100 observation. It's very easy to find out the average. It's very easy to find out the outlier. But in real life, you will get a minimum 10,000, minimum 50,000 data set. I mean, the size would be like 50,000 data points are there, observations are there. How will you do it? Now, if you use R or if you use SAS, it depends. You need to write a code and you need to tell R that give me the mean median. If you just in R, if you just check the summary of your data, it will give you, by default, it will give you the mean, median, this concept. Now, what you need to check, how to detect, is there any outlier or not, using this mean, median concept. You need to check the difference between mean and median. Okay, if the difference is very high, suppose it's 50, it's 100, for time being, if it is 5 or 10, you can consider it as an outlier, because we can understand arithmetic mean is affected by outlier. So extreme values are there, either it would be very low, the arithmetic mean, or very high value. And median is, suppose you are getting, okay, let me just write it down. Suppose arithmetic mean you have got 50 and median you have got 52. What if we had 1, 2, 3, 4? Then you need to add this 3 and 4, dividing it by 2, you will get your median. So even number, you need to take two middlemost values, take the sum, divide it by 2. Okay. Okay. Now suppose if you are having arithmetic mean as 50, welcome Abu, and 52 as your median. What do you think? The difference is high? Very high. It's only 2, right? So I might consider it as there is no outlier. Okay. Now let me clear something. See, outlier treatment is totally subjective. Means it differs individual to individual. I may consider this as there is no outlier because the difference is only 2. You might consider it as outlier, and then you can take care of that matter. This taking care of that outlier is not coming under the stat part. This you will do when you will do R or any other statistical software. Okay, the statistics is used to find out or to detect outlier, whether there is outlier present or not. Okay, so this 50 and 52, the difference is very minimum, so I consider it as there is no outlier. Now in place of 52, suppose my median is 36 and my mean is 50. Okay, so you can consider it as outlier, because you can see here my difference is what, 14, right? You might consider it as outlier. What I told you, that there is no hard and fast rule that the difference should be this, then only you will consider it as an outlier. Yes, if suppose so, the difference between mean and mode is almost zero. Okay, so that means there is no outlier. Okay, so in this way you need to compare between the value of mean and median, and if the difference is very high, definitely there would be an outlier. If the difference is not so high, you can check or you can use other concepts of statistics or your software like box plot and all those things to recheck whether there is outlier or not. So to find out the outlier, to detect the outlier, mean median difference is one of the famous or very important measurement. Have you got my point, guys? But it is totally subjective in nature. It is not hard and fast rule. For me, this two difference is pretty cool, right? I'm okay with it. But for you, you might think that okay, difference is two, that means outlier is present. So you need to take care of that outlier. Okay, so this concept is very important. Now in interview also, they might ask you, say, which one is if suppose outliers are present in your data set, how will you determine or how will you detect the outliers using central tendency concept? So then you need to say that I would check mean median concept, the difference between the mean value and the median value, and if the difference is very high, I would consider that there is an outlier. Then they can ask you, see, why is it so? Why you are considering mean and median difference? Okay, then what you will say, that mean is affected by outlier and median is not affected by outlier. So if we compare the value between these two, we can understand that whether the mean is affected by the outlier or not. If the difference is very high, that means that outlier is present. So we have got a high difference between mean and median. This would be your answer. So have you got my point? It's very, very, very important. Hi, Mohammed. Actually, you are right, I think, Shakil. Okay, Parth, you are fine. So, Rajamani, Abu, Ravinder, it's showing offline anyway. So, Rajamani and Abu, is it clear? Is very important, guys. It's very simple, Abu. Actually, you are taking it very complex. It's very easy. You know the things. Mean is affected by outliers, isn't it? Answer me, Abu. Mean is affected by extreme values, isn't it? So from then I am using the concept outlier. Outlier is extreme values. So I think you are not following the class, right? See, outlier means the extreme values. Just like in place of 9, if you are having 900, which is not compatible with other set of data. Extreme values. So in place of 9, suppose you are having 900. So that is your extreme value, that is your outlier. So mean is affected by these outliers. Okay. For median, what we knew? We are arranging it in ascending or descending order. So if you are having 500 in place of 5, will it affect your median? So it is not affected by your outlier. Now, for a same set of observations, suppose for this set of observations, 2, 5, 8, 4, 6, 9. For this set of observations, you are calculating arithmetic mean or mean, and you are also calculating median as well. Okay? For same set of observations. Okay? Suppose actually, Mohammed, we have discussed so many things. Okay, so let me finish this thing. Then I would repeat some concepts for you. Okay? I will give 5 minutes break to other guys, so then I can discuss those things. Okay, Mohammed? Is it fine? Okay, and remember, please try to join it by 10 or 10:05 because we start the class by that time only. So please try to join there because it's good for you. I can repeat, but this is good for you. Okay, thank you. Anyway, so Abu, suppose for this part, you are having 5.67 as your arithmetic mean, and suppose 5.6 you have got your median. Okay, the difference is high or low? Is there any such significant difference between this arithmetic mean and this 5.6 as your median, Abu? Answer me, please. Not really. It's no, I mean, no such differences. Yes, right. So no difference is there, right, Mohammed? So, okay. So when the difference is almost like, even if it is suppose 6 or suppose 7, the difference is minimum. So that means we consider like there is no such extreme values. There is no such extreme values because the mean and median's difference is almost, I mean, 0. There is no such significant difference between these two values. Right, guys? Okay. Now, suppose in place of 9, we are having a big value. Let's say 900. And suppose we have got a median, sorry, we got arithmetic mean as 100. Now consider this 100, suppose. And we can see the median is 6. Now you tell me the difference is high or not? Difference is significant or not? Muhammad and Abu? If the mean is 100, little high, it's high actually. It's not little high, it's high. Okay? Yes, obviously it's subjective in nature, so you can use this little high as well. Okay, and Muhammad, are you getting it? Suppose here you are having 900 and let's say you have got arithmetic mean as 100. In place of 9, if you are having a very big value, okay, and you have got a very big value of mean. And median is same, because median, how we are calculating it, arranging it in ascending or descending order. So it's almost same like our previous one. So 6. Okay, difference is high. That means there must be some extreme value present in our data set which has affected our arithmetic mean. So this is how we detect outlier. The values would be given by the system. When you will use the software, you don't have to calculate it manually. You don't have to calculate median manually or median mean. You need to, yes, you will get it. You will get these values and you need to compare these values. If the difference is very high, it means there is a very extreme value in your data set. That means outlier is there. If the value is almost same for mean and median, that means outlier is not present. This is how we detect the outliers in our data set. Outliers means extreme values. Extreme values might be very large or very big value and very small value, like minus 0.00001. This is also an outlier. Okay, very low or very big value which is not compatible with other set of observations. So Abu, now is it clear? Thank you. Last concept is your mode. Now, when do we use mode concept? The value for which the highest frequency is there. Okay, that means suppose if I want to know, one example is which shoes number is having the highest sales in last month. Which shoe number is having the highest sale? So suppose shoes number 5 is having highest sale. Highest sale means the highest number of occurrence. Most of the people have bought this shoe number. So that means number of occurrence is highest for this shoe number size. This is what your mode. The value for which your number of occurrence or the frequency is highest, we are calling it, yes, right, which occurred most frequently, it is mode. So the example is, when do we use this mode concept? Just like this, like suppose I am considering one student's last 5 years performance, okay, from 5 to 10, okay. So for which subject he got maximum number for most of the cases. Suppose for maths he got 90 above in each year. So most of the time he got 90 above in maths. So that means the frequency is highest for maths. So I will consider that he is very strong in maths. right? So this is how we can use the mode concept in our analysis part. Got my point, guys? So this is what your mean, median and mode concept. And last parts are median. When we are using median, what we did, we actually divided the whole set of observations into two parts, right? We took the middlemost value. That is what our median consists. So we have divided the whole set of observations into two parts. If we divide the whole set of observations into four parts, suppose what we call a year, a particular 1 year is having 4 quarters, right? Quarterly review, we did it. So the 12 months have been divided into four parts. So first quarter, second quarter, third quarter, fourth quarter. So when a set of observations is divided into four parts, then we are calling it quartile. If the whole set of observations is divided into 10 parts, we are calling it deciles. You should remember the concept only, okay? Deciles and percentiles means when the whole set of observations is divided into 100 equal parts. We are calling each part as percentile. So this is what our central tendency. Is it clear, guys? Thanks, Abu. Anyway, other guys, please let me know. Okay. Mohammed Parth, I hope you are also clear. Okay, thank you. Anyway, so let's take 2 minutes break. Okay, and then I'm going to start the dispersion concept. Yes, Abu, I will try to discuss dispersion at least. Okay, and if it's possible, skewness, or we can continue it next day. At least dispersion we can start today. Okay, guys, I hope you people have no problem. So just let's take 2-3 minutes break and okay, Abu, then you can leave and you can take the videos, and if you have any further queries next day you can ask me, okay, before I start the new topics. You can leave. And okay, and Parth and Rajamani and Mohammed, do you have any problem, or Arindam? You people can continue, right? Okay, thank you. So let just take 2 minutes break. Okay, have some water and all, and then we are going to discuss the dispersion concept, and skewness kurtosis next day also we can discuss, not an issue. Okay, guys, so I'm back. So let's start the dispersion concept and then I will conclude today's session. Okay, so uh, Abu Path Rajamani, are you there, guys? Because I'm starting. Okay, thank you. Yeah, sure. So dispersion is what? Suppose you can see here two series of data you are having, means sample data you have got. Okay, so for these two series of data, you can see the average means the mean is same, the median is same. Sometimes you might find that mode is also same. Okay, now if you have the option to choose between the series 1 or series 2, series 1 means a set of observations, series 2 another set of observations. So which one will you choose? Because if you consider the average and median part for both the series, these are same. Now if you have an option to choose among them, which one will you choose, guys? Series 1 or series 2? Which set of observation is better? Okay, Rajamani, Parth and Abu. Great. So why is it so? Because here we can see it is compatible, right? They are very close to each other. Yes, spread is less. Spread means variation. So this is what our dispersion concept. We always want to get a data set with less variation, least variation actually. Okay. Now this dispersion concept tells us that what is the nature of this data set. Most of the data points, they are compatible with each other or not, or they are very much fluctuating, the variation is very high or not. So if the variation is very high, they are not compatible, okay, or no such consistency is there, it might affect your analysis. That's why it's very important to understand the nature of your data set. Okay, so in dispersion, we might have so many measurements, but I have considered those measurements which are actually used in our analytics part. One is range, another one is standard deviation, another one is coefficient of variation. Range is the simplest one. A set of observations you are having, the difference between maximum value and the minimum value is termed as or is called range. Okay, so what is range? The difference between the largest and smallest observation is called as range. Again, this is also very important for your interview. Sometimes they might ask you, like, what standard deviation concept do you use to detect outlier? Okay, one of the dispersion concept which is used in detecting outlier is range. Range is used to detect the outlier. And how to calculate range? Obviously, your system will do, but actually range is calculated by taking the difference between the minimum or the lowest value and the highest value of a given set of observations. So that is what your range concept. Got my point, guys? Next is your standard deviation. Now, it is the square root of the arithmetic mean of squares of deviations from M. It sounds very difficult, right, guys? So you don't have to remember that because no one is going to ask you that thing. Standard deviation, what does it actually mean? It tells you how tightly your data is clustered around the mean. Means you are having a mean, arithmetic mean, suppose. So an average value you are having. So what you are doing, you are comparing each and every data point with this mean. Okay, you are looking at the difference between each data point's value with its mean. So if they are very close to each other, that means they are very compatible, consistent. So it will look like this. Small variation is there. If it is flattered in this way, that means what? Most of the data points, they are far away from your mean value. So that's why here the variation is very high. So standard deviation close to zero, better the sample, and that is better for your model. So we always want to get less standard deviation. If it is close to zero, what does it mean? It means that the variation is minimum. Most of the data points, they lie very close to your mean value. So they are compatible, they are consistent in nature. So you have a good set of observations or sample, and you can expect that the conclusion what you will derive after analyzing this data set would be good one. So is it clear, guys? And this is the formula. And standard deviation for sample is indicated by small s. For population, it's sigma. So is it clear, guys? Mohammed, did you have any connection problem? You just logged out. So yes. Okay, Rajamani, thanks. Parth, Parth, is it clear? Okay, thank you. Ravinder, when we were discussing, okay, so you just missed the mean part, I think, central tendency part, because I saw you are offline. Some connection problem might be there. Mohammed, we have started. Yes, I got your point. So you just take the videos, okay, and it would be clear. Yeah, Mohammed, I also got your point. No, not an issue. Whatever we have discussed, it is already being recorded. So you will get it. Okay. Go through it. If you face any problem in understanding, or if you have something to clear out, so next day session you can clear it. Okay. But try to be there by 10 to 10:05. Okay. Okay. So we are actually, yes, guys, and Sajid is sharing the link with you people. So please click on it, and I think some review also you have to give regarding this class.
Hello,
So
guys.
please,
Hi. Sorry, Matusha, to interrupt you in between. Okay.
no, it's fine. It's fine. Mhm.
Yeah. So, guys,